Soaking ourselves in the immeasurability of the universe, we individuals have reliably examined the opportunity of whether we genuinely are the fundamental species to have a planet checking the stars out. Considering faraway universes and examining the potential forever, past our little blue planet, that potential has finally captured NASA's attention. The boss has just proclaimed that the James Webb Space Telescope has discovered something marvelous at the edge of our incalculable area. The James Telescope has, notably, observed Proxima B, the closest potentially habitable exoplanet to Earth. We evaluated that a potential city made by watchful life had been recognized, which to date we don't have any clue about. The new James Webb disclosure shows how the quality of the artificial lights of the city on Proxima B has been detected. So, come along with us on the faltering journey to Proxima B to see the nuances of this discovery. As shown by NASA's boss, the James Webb Telescope might have effectively recognized life on Proxima B, an exoplanet found just 4.24 light-years from our Sun. Proxima B has become an object of fascination due to its potential to harbor life. This exoplanet circles its matching star, Proxima Centauri, a red dwarf that is significantly more humble and cooler than our Sun. Discovered in 2016, Proxima B lies in the star's habitable zone, also called the Goldilocks zone, which is the region around the star where conditions could allow the presence of liquid water, a fundamental component for life as we know it. Proxima's proximity to Earth and its position within the habitable zone have generated immense interest and hypothesis about its ability to support life. However, it is crucial to remember that the habitability of an exoplanet is a complex riddle involving various components. Proxima B is described as having a mass around 1.3 times that of Earth and an orbital period of about 11.2 Earth days, meaning it completes one orbit around Proxima Centauri in that time. Things are not as straightforward as we might think. How the planet is Earth-like in size and orbits a red dwarf doesn't guarantee that it is a perfect imitation of our world or that we can all move there. The viability of Proxima B isn't completely settled. Various factors play a role, one of which is the planet's atmosphere, which acts as a protective shield and plays a crucial role in maintaining temperature and supporting life. At any rate, the specific composition of Proxima B's atmosphere is still unclear, making it challenging to definitively determine its viability. James Webb Telescope analysts are managing strategies to focus on the atmosphere of Proxima B. A critical tool in this process is the James Webb Space Telescope, which allows scientists to analyze the light that passes through the exoplanet's atmosphere during transits. This will provide information about its characteristics and help them search for possible biomarker molecules that could indicate the presence of life. Another significant factor impacting habitability is the presence of water. Despite Proxima B being in the habitable zone, it is essential to determine whether it has a sufficient amount of water to be considered suitable for life. Water is a fundamental piece of the puzzle, and scientists are looking for signs of liquid water on the planet's surface, whether as oceans, lakes, or streams. These snippets of data could be essential in assessing the potential for life on Proxima B. The presence of water in various states, like ice or vapor, is also considered vital since water availability is crucial to support biological cycles and is viewed as a fundamental characteristic of habitability. The existence of Proxima B raises questions about its environment. Scientists must also investigate factors such as temperature, pressure, and geological activity on Proxima B to assess whether the planet is within a suitable range for life to thrive. Extreme conditions, like high radiation or extreme temperatures, can make habitability difficult. Stable conditions are also critical. Volcanic eruptions or seismic activity can disrupt viability. However, Proxima B is thought to be in a tidally locked state, meaning that one side of the planet remains forever in darkness while the other side is perpetually illuminated by the star. The temperature differences between the illuminated and dark sides could create conditions that impact the planet's habitability. These are just some of the aspects scientists are considering in the search for habitable planets. Researchers are investigating the chemical composition of Proxima B to analyze the presence of organic molecules, such as amino acids, and other compounds essential for life. They are also examining whether the planet receives enough energy from its star or other sources to fuel biological cycles and allow life forms to develop, reproduce, and thrive. Despite all these studies, the question arises regarding whether Proxima B indeed possesses all the necessary components to be considered a habitable planet. Is there substantial evidence for this? Well, the discovery of Proxima B in 2016 was an astonishing achievement. Space scientists used a high-precision instrument called the High-Accuracy Radial Velocity Planet Searcher, HARPS, to detect the subtle gravitational tug of an exoplanet around Proxima Centauri, our nearest neighboring star. This high-precision spectrograph, located at the La Silla Observatory in Chile, has been instrumental in the discovery of various exoplanets, including Proxima B. HARPS works using the radial velocity method, also known as Doppler spectroscopy. Its capacity to detect exoplanets lies in assessing the subtle changes in the star's spectrum caused by the gravitational pull of a nearby planet. These movements, known as radial velocity or Doppler shifts, occur due to the slight wobble of the star as it is pulled by the gravitational influence of its companion planet. HARPS employs optical fibers to gather light from the target star and guide it to an internal spectrograph. Inside the spectrograph, the light is dispersed into its various frequencies, allowing astronomers to analyze the star's spectrum in detail. This way, researchers can determine the star's radial velocity with remarkable accuracy. To achieve the high level of precision required for exoplanet detection, HARPS uses techniques that incorporate a temperature-controlled environment, allowing for stabilization of the instrument and minimizing the effects of atmospheric variations that could disrupt precise measurements. What's your take on Proxima B? Do you think it is habitable and that in the future we will have the chance to move to this intriguing exoplanet? Since the dawn of time, humanity has asked itself questions that evoke profound curiosity. What lies beyond what we understand? What exists beyond the confines of our universe? The answers remain tantalizingly complex. The James Webb Space Telescope has found something immense and spellbinding in the far reaches of the universe that could. Moderate material science. What exactly has James Webb found at the edge of the universe? Why are analysts so empowered? We invite you to research how this telescope has tracked down something tremendous at the imperatives of what we can see. If you're excited about keeping fully informed about news from the universe and its natural factors, get involved with our channel. Be sure to like this video and turn on the notification ring. Albert Einstein cultivated the theory of gravity that transformed Newton's theory in 1916. He applied it to the universe, showing that the universe couldn't endure stillness and must be moving, expanding or contracting. In 1929, the space master Edwin Hubble observed that galaxies were moving away due to the Big Bang. This is the expansion of the universe, where the distance between galaxies is consistently growing. One can speculate about a perpetually expanding universe or one that folds back on itself, like the outer layer of a ball in a higher dimension. Some argue that the universe has an edge since it was born in the Big Bang a long time ago. Consequently, we can see galaxies whose light has traveled a distance of about 13.8 billion years to reach us, outlining a spatial circle centered on Earth called the observable universe. As a general rule, the universe is 92 billion light-years across, and the limit of the observable universe is the cosmic microwave background, equivalent to the horizon of the sea. We know there are countless galaxies beyond it, however, their light has not yet reached us. Can the James Webb Space Telescope reach the edge of the universe? It is several times more powerful than previous telescopes and can detect the faintest infrared light from the earliest galaxies and planets. However, we still don't know what the telescope will see when it's pointed toward the edge of the universe. The universe is divided into the observable and the unobservable, with the observable being everything we can see by detecting radiation with our eyes, and the limit of the observable being the cosmic microwave background that was emitted 13.8 billion years ago. At that time, the universe was clouded like a thick fog. Some experts believe that there are gravitational waves and neutrinos coming from much farther regions, but this cannot be confirmed due to technological limitations. Cosmologists suggest that to better understand the universe, we must consider that what we notice is just a small piece of a greater reality. Finding galaxies like Chime 2744Y1, which lies at the farthest edge of the universe, can help us better understand this reality. This galaxy is so far away that it took 13 billion years for its light to reach us. Astronomers can see it in its youth, precisely as it was billions of years ago. The Spitzer, Hubble, and James Webb telescopes collaborated to track down this galaxy, as each uses different parts of the electromagnetic spectrum to gather data. By combining information from all three telescopes, astronomers can examine galaxies that rely on light from different times, farther away than any telescope could see on its own. Astronomers from the Astronomy Association in Canada and the University of Laguna used the Hubble Space Telescope to discover the galaxy AEL 2744Y1. They calculated its distance and the number of stars using parts or materials. They also used a gravitational lensing technique, which acts like a magnifying effect, focusing light from distant systems through galaxies closer to Earth. The galaxy is small compared to our Milky Way, with a width of about 2,300 light-years, yet its formation rate is many times that of the Milky Way. The redshift of the galaxy CHIME 2744Y1 is 8, indicating that its light has been stretched toward longer wavelengths due to the expansion of the universe. Before the discovery of CHIME 2744Y1, the most distant known galaxy had a redshift of over 7. However, astronomers have now found something much farther away, a galaxy called DS16C2M, identified through a distant supernova. These incredibly massive explosions signal the last throes of a star before it dies. To understand how stars work, we need to observe their demise. Massive stars consume large amounts of nuclear material in their cores, producing a vast amount of energy. This energy creates pressure that prevents the star from collapsing. When you see a star in the night sky, it is due to a balance between two opposing forces. Impressions of the components on Pluto's surface, including its edges, are like those tracked down on Earth. The slopes on the planet are formed by the improvement of wind that conveys particles and stores them in unambiguous districts. In a way, the slopes on Pluto show remarkable characteristics. They could have been shaped by wind movement as well as by the dissolving of nitrogen ice, causing sand-sized methane ice grains to be lifted by rising gases and subsequently wild once airborne. Other than that, Pluto's edges are basically greater than those on Earth, with some as tall as mountains, what's more, seriously expanding for certain miles. This is legitimate because of the lower gravity on Pluto, allowing particles to be moved even more effectively, creating these imperative components. Another intriguing piece of Pluto's landscape is the presence of lumps of ice-like plans dispersed across its heart-shaped region. These plans emit an impression of areas of ice that have parted away from greater formations. Each piece weighs 1 to a couple of miles wide and seems to float across the frozen surface underneath. Scientists believe these ice sheets contain frozen water, since water ice is less dense than nitrogen ice. When they break off and are crashed into Pluto's heart, possibly through chilly streams, they are subject to the development of the nitrogen ice underneath, achieving the curious shapes found in this area. The telephone-like advancements covering Pluto's heart also reveal information about the planet's geological cycles. These advancements, seeming to be a connection called convection, happen when a fluid is unevenly warmed, whether by the sun or a percolating pot. This convection cycle is acknowledged to be a characteristic of Pluto's dynamic and consistently changing surface, uncovering insight into the complex interactions forming this faraway world. The presence of convection on Pluto suggests that something under its heart-shaped region is warmer than the surface. This causes the frozen nitrogen plates to travel continuously. By eagerly checking out the photos, scientists noticed that the ice shells tend to collect around these convection cells and are likely being moved to the edges by the fundamental forces. Scientists continue to focus on these arrangements, too, looking for answers to the intricate questions regarding Pluto. Each time we look at Pluto, it seems to offer something new to discover. What's more, Pluto is only one of perhaps many dwarf planets in the Kuiper Belt. It's exciting to consider the wonders that could exist on other small planets like Haumea or Makemake, which we haven't yet had the opportunity to explore. Ideally, one day we'll have the chance to observe their frozen grandeur and unlock the insider secrets they hold. With the launch of the James Webb Space Telescope, we stand on the very edge of a new era in space exploration. Pluto's status as a dwarf planet is quickly transforming into a relic of the past as NASA reveals clear, detailed pictures of refined geological features that have recently emerged on its surface. The amazing pictorial references mark a significant advancement, showing the dynamic nature of this distant world. It's astounding to think that just a couple of gigabytes of data could open up a vast expanse of immense opportunities for us. The overflow of information gathered by missions like New Horizons and the James Webb Space Telescope offers new insights into the mysteries of our universe. With each new revelation, we inch closer to understanding the complexities of celestial bodies like Pluto and uncovering the insider truths they hold. For certain, the potential of what lies ahead in our exploration of the universe is both exciting and moving as we continue to stretch the boundaries of our knowledge. The journey into the depths of space promises to be as intriguing as ever.